Let's get these notes after I calibrate this. Alright, so we're going to be modeling with cubic functions. Remember, cubic is when it's x to the third power. Our graph looks like that. That's menu 417, I believe. Okay, diving board is a platform that someone can use to dive into a deep water pool. Diving boards typically have enough flexibility to allow a diver to bounce before leaving the board and entering the pool. Diving boards have a heel end on the pool deck, which is where the person steps into the diving board, and a toe end that hangs over the pool. Diving boards also have a fulcrum that balances the board. When a person stands on a diving board, it bends or deflects slightly due to the person's weight. What questions could you ask about the deflection of a diving board? That could be answered by collecting data. Okay, so obviously when we're talking about deflecting, we're talking about the distance that it goes up or down, right? The bend it has. There it is. When a person stands on the diving board bends beneath the weight of the person. The farther the person stands from the fulcrum of the diving board, the more the diving board bends or deflects from the horizon. Okay, so you got x being how far you're going horizontally, okay, and you got that vertical f of x. So, table below shows the amount of deflection in the thousandths of an inch when the same person stands x feet from the fulcrum of the diving board, okay? So you got horizontal distance x, and then you got deflection measured in 0.001 inches. All right. Cool. So, does the data set appear to have a constant rate of change in deflection? Okay. Constant rate of change. So, let's see here. 448 minus 116. Okay, you can already tell. No, it does not have a constant rate of change. Okay, it's not constantly changing by the same amount. It is increasing, okay, consistently, but that doesn't mean it's a constant rate of change. Let's subtract these numbers here. So let me get a calculator. So let's keep subtracting. About 24. Again, with the subtraction. The first difference. Alright, so the first difference is not constant, and it's not even close. It keeps increasing by a lot, okay? Number 2, does the amount of deflection appear to increase by the same factor? Again, by the same factor, let's divide these. Over here I'm going to divide. Okay, you can't divide 116 over 0, but let's do 448 over 116. 3.86. 972 divided by 448. 2.17. 1.71. .5. So if it goes the ratio that we are going to be multiplying as a factor, if that's decreasing significantly each time, no, not by the same factor either. Okay, so we found the first difference. It's not linear. Okay, find the next difference. Okay, so 216 192, 168. Now, is the second difference pretty much the same? So 216, 192, 168, 144. Those are decreasing significantly each time. That is not quadratic, okay? So no. Let's do a third difference. Third difference. So 216 minus 192. Sorry, 190. My bad, 192. Look at that. It is cubic because the third difference is the same. Okay, use the patterns and the finite differences to write a function rule that describes the data set. So again, this is menu 4, 1, and I believe it's 7. Okay, so let's take this thing to the calculator. It's going to take forever to load, but nonetheless. We're going to go into lists and spreadsheets. We're going to type in this data, and my suggestion is you type it all in. Okay, that way you have the most accurate thing you could possibly have. Do. Take it forever. By golly, there it is. Let me close this 3 blocks of that one. So, go to a list of spreadsheets. We go over to X and Y, 0 through 5. 0, 116, 448, 972, 1604, and 2500. Okay, so at menu 4, 1, and do you see 7 says cubic? Hit menu 417, X for X, or Y for Y. Hit enter twice, and you got A is -4, B is 120, C is 0, D is 0. Remember, E to a negative and E with a negative, those end up rounding to 0 because they're so incredibly small. For some reason, the calculator doesn't put 0 when it should. So nonetheless, -4 and 120. Get that equation. -4 x cubed plus 20 x squared, right? 120 x squared. And it would be plus 0x plus 0, but you're not going to write that, okay? Actually, here's what you're going to do. Watch this, watch this. Whoa. No. Kids. Okay, let's try this again. Plus 0, 0, nope, 0. Okay, you can't draw 0 with this pen. Anyways, use a graphing calculator to graph the function rule over a scatter plot of data. Okay, so can you graph it? Yes, you can. What do you notice about the function rule and the scatter plot? Okay, let's graph x cubed. Okay, we're going to graph the parent function. That's what it's where it says. Oh, no, never mind. We're not doing the parent function. We're just going to hit graph, take a look at it, okay? Two for graph, negative 4x caret 3 plus 120x squared. Ooh. Plus 120x squared. Alright, we hit enter. You can see it's very narrow. Oh, it'd be cool to zoom in, but there's that. Compare the domain and range of the data set and the domain and range of the function rule. Okay. So since we're talking about distance, okay, x has to be greater than 0. Y will be greater than 0. Okay. And you can see that right here, starting at 0 and going up. Okay, and let's make sure that greater than or equal to 0. It includes it. Okay. Now they want to know what's the deflection. Okay. What's the y value if the person stands at the x value of 10? So let's do that. Control T. Let's look for 10. 8,000. So now the answer we get is 8,000. But if you remember what it says, deflection is 0.001 inches times 0.001 inches, which equals 8 inches. Okay, I know that's kind of weird, but you got to look at what they're measuring their values at. So are the x-intercepts of the function included in your data set? Why or why not? Okay, yes. Okay, because when y is 0, no one is on the board. So you can include 0, I mean that's a measurement. What dimension of the diving board represents the greatest possible x value that can be contained in the data set? What limit does that place on the domain? Okay. So how far out, so how long is this board? Right? So did it tell us over here? I don't think it did. Well, so theoretically, length of the board is gonna limit my domain. Okay. What limit does that place on the domain? The domain limit depends on the length of the board.